First problem. Sulfur dioxide. First thing we have to do is come up with the formula of it. What's the formula for sulfur dioxide?
Sulfur is
Okay. And
S.
O2. So that's the first thing that you do. You just put down the formula for that compound. Then what I do is I write S and I write O. Now what is O almost always going to be?
Negative.
-2. So I put -2 right there for O. Then you put the charges in up here. If each oxygen is -2 and there's 2 of them, -4. And if the whole thing equals 0, what must S be? +4. Those are the oxidation numbers. S is a +4, O is a -2. What's that mean? If something has a -2 charge, did it gain or lose electrons?
Yes.
Gained. And if it's 2, it gained how many? 2. So what did sulfur do? Lost 4. Do you see how that balances the charges out to 0? Any questions on this? This is the basics. Zach, you look lost. No. Next one. What about sulfate? What is that? Close.
SO4 -2.
With the -2 charge. So now, on the last one, it equals 0, but now it has to equal what?
-8.
It has to equal -2. Remember, on our rules, it's going to equal 0 or the charge of the anion. Well, here, isn't this the charge of the anion? So that's what our total has to equal. So again, we put S and O. What's O going to be? -2. And so now, doesn't that equal -8?
Yep.
And if the whole thing has to equal -2, S must be a
6.
+6. Okay, let's do that one again. You guys look lost. Any questions on this up here? Everybody see that sulfate is SO4 with -2 charge. Okay, each oxygen is a -2. Is that right? Okay, so we put -2 in right there. If there's 4 of them, doesn't the whole charge equal -8 for the oxygen? Okay. And if the whole thing added together equals -2, doesn't sulfur have to be a +6?
Yeah.
That's what it equals right
So can you just take that and
there. Okay.
never mind.
Yep. If you add these two things up, Tyler, what do you get? That's what we want to get right. Alright. First thing I want you guys to do is get the name or the formula of that. Sodium arsenate. Sodium's Na. What's arsenic?
AS4
-3. What's sodium charge? +1. And so our formula comes out to look something like that. Correct? Right? So I write Na, I write As, and I write O. What is O?
-2.
-2. Now, is it always -2? For what we're going to do, yes. When you get to college, no. There are going to be some exceptions. So I put
we always use -2 for
what we're doing, yes. When you get to college, no. There'll be some exceptions. You know, like hydrogen peroxide, H2O2, O is a -1, then I'm saying -2. Okay, so You got -2 there, and if there's 4 of them, oxygen equals
Negative
-8. Okay, now do we do the middle one or do the cation?
the cation.
Do the cation. And what's sodium's charge?
1.
+1. And if there's 3 of them, that equals what?
3.
+3. And so what must AS be if the whole thing equals 0?
No.
+5. Those are the oxidation numbers for sodium arsenate.
So the numbers.
So
Got it? Oh,
you're adding. Okay, so after you have the charge for like oxygen, -2, and then there's 4 of them, it's -8. So you're adding the -8 and the 3 together. So that's what you're adding together.
everything up here. So like this O is that
Alright.
at A. So this plus this plus this better equal 0.
Okay.
Unless it's an anion or a cation, like the one we did before. Another one?
Yeah.
Yeah.
Are the numbers like in here? Are in the oxidation numbers? Do they always have to add up to 8?
No. Okay. They have to add up to 0.
Alright.
It's black, isn't it? Sodium sulfate. What's sodium?
Na.
What's sulfate?
SO4 -2.
And what's sodium's charge?
1.
So it'll be Na2SO4. Is that right?
Yep.
Okay. That's the first step. See how important nomenclature is?
Yeah.
If you don't know how to name things, you can't even start these problems. NaS. What's O?
-2.
Cool. And so if there's 4 of them,
-8.
what's sodium?
1.
And if there's 2 of those,
2.
those are 2. Now this whole compound has to equal 0. So what must S be in order for that equation to equal 0? Starting to make sense?
Yeah.
You guys want a tough one?
Yes.
Sure.
All right, here we go. You guys do this one. You guys know who that is? That's Poppy Montgomery on the Unforgettable. Is that what you guys got for a formula?
Yeah.
Okay, so that's the first step. Got it? Want to go over it or want to wait?
Do you have to take the -2 to the 4 and then the 3?
Yep.
Okay.
So if O is -2, then that equals -8.
Yeah.
And then if there's 3 of those, that equals -24.
Are you gonna take the 3 to the carbon too?
Uh-huh.
Okay.
Alright, hold on.
Yeah, I did.
Yttrium is a +3.
Oh, yeah.
Oh,
And if there's 2 of those, then that equals a +6. Right? I want this number in my oxidation. But in order to figure them out, yeah, you got to go all the way through. You would say oxygens equals a -24.
The charge goes.
Yes, the charge will go here. All right. So, does everybody see where I got 24?
Mhm.
Everybody see where I got 6? Okay, so what we got to do is we got to figure out what this middle one is. Well, the whole thing, it must be a +18, right? So that +18 goes right there. Is that the number I read over here?
no.
No. Now, if there's 3 of those, well, we can do it either way you want. If there's 3 of those, wouldn't that equal +6?
Yeah.
And if there's 2 of those, each one must be a +3. How do you check your answers?
You pick one.
You could just put those numbers back in here and see if they equal 0. Oxygen is -2, so -2 times 4 is
Negative.
-8 times 3 is -24. Carbon is a +3, so +3 times 2 is 6, plus or times 3 is 18. And yttrium is +3 times 2 is, does that equal 0? There you go. One last thing. I don't know if I don't recommend this, but if you need to get the hang of it, you can carry this 3 through before you even start the problem. So you could write this Y2C6O12. And then just do the problem like you normally been doing. Okay, now I only want you to do that for oxidation numbers until you get the hang of it. This is the actual formula of it. You can't write this down as the formula. But this will work for oxidation numbers if that helps you to start with. Got it? Make sense? All right. You do have an assignment for today.
Yes.